sure that I'm recording. Because just a quick recap of what we talked about last lecture is that software product lines and variation modeling is about mass customization. Mass customization is somewhere in the middle between full customization and just pure mass production. Mass production doesn't allow for any sort of customization while you are pumping products quicker and faster and cheaper. You're losing a bit of the market because not everybody wants the same exact thing. Okay, yet at the same time, just going on full customization mode is very costly for every product that you produce. It's also costly in terms of time. Each product takes the same amount of time. So it's definitely not good from the perspective of the customer. In general, software product line, it does allow that we get the best of both worlds. So we have some level of customization there while also achieving the benefits of producing things quicker and cheaper at the cost, obviously, of having a bit of an upfront investment that we do at the very beginning to establish the product line to begin with. All right. Now, when we are doing the variation and the customization that within the realm that is allowed, we're basically choosing from different features. Okay, like we've looked at the BMW website. I think it was Naif, or I'm not sure if who it was, but was kind enough to actually be able to show us the website because my computer wasn't showing it for some reason. And then you can see as you go through the website building our own car that some features are just not compatible with each other. All right. So BMW does offer all of these features. They offer all these components that you can have in your car, but some components just cannot fit with each other. And it's the job of the website, the system, to tell us which can fit with which and which cannot fit with the other ones, right? Sometimes it's a situation where if you're gonna have that one, you're gonna have this feature, you gotta have this one as well, okay? Or if you have that feature, then you cannot have that one, right? It could be a situation where you have to have something that deals with that feature, for example, safety. Now, the specific way to deal with safety may be left up to you. You might choose this approach, that feature, and or a combination of them, but at least, for example, you have to have one. And this is where feature diagrams come into play. This is going to be the topic of today's lecture. So I'm going to be talking about feature diagrams. Okay. With feature diagrams, we'll see from a modeling perspective the ability to decide and show all the different variations and the possible combinations that exist, what is allowed and what would not be allowed. All right. Now, just to be clear, when we create a feature diagram, we're not showing a specific instance of a product. We're showing the different possibilities that that instance of the product can have. All right. So the most basic notation is that little box over here. Okay, and this is basically, it's called a root. So it comes in the form of a box. So the root is the very first feature, but every other feature looks exactly the same. It's just a box like that. When we have a straight line with a filled in black dot, that means there's a mandatory relationship between them. Otherwise, we have with the hollow circle would be an optional relationship. All right. This tree line is called an AND relationship. The one that's like a tree line with a hollow semicircle in it, almost a semicircle, it's called an XOR. It could be multiple lines coming out of it. It doesn't have to be just two, by the way. Let's see. All right, this over here is the OR relationship. So it's just like the previous one. The previous one is called an XOR. So You can have one and one only, but with the or you can have one or more, but you can have at least, you have to have at least a minimum of one. All right. Um, this is a required, means if you're gonna choose feature A, you have to have feature, you have to pick feature B as well. This is an exclude, means if you choose feature A, you cannot have feature B, and if you have feature B, you cannot have feature A. This over here is a feature cardinality, a minimum and a maximum, and an N and an M. All right. It's kind of like the multiplicities. And this is applicable to a feature. This is applicable with the square, with the brackets, sorry, with the angled brackets at the end. This is called a group cardinality, which means it's applicable to not just one feature, but a set of features together. I know all of this probably doesn't make sense at this point, so let me just before I well, I'm gonna skip that slide for a moment, and then we'll get to it later, right? All right, so this is an example of a feature, very simple. It's a box. You write down what is the root element, okay? And every other feature that comes afterwards is going to look exactly the same, okay? So the root element, the root feature, tends to be the name of the product itself, what it is that we're delivering. So we're delivering a vehicle, we're delivering a car, we're delivering a home, we're delivering a phone, okay? So we put that at the very top, and then we decompose that vehicle, we decompose that phone, that home into smaller components, i.e. smaller features, all right? This is an example of saying, okay, a vehicle consists of the three elements over here, all right? So this is a feature, and you can see it's the same notation as the root, makes no difference because it's the same exact concept. We say that a vehicle is broken down into those three components over here, okay? You have to have an engine, you have to have transmission, because we got the black circles, but because this is a white circle over here, this is an optional feature. Now, that top half over here, that part, if you remember, this is an and relationship, okay? But the and is not really a hard and that we like we know in digital logic and in other programming language that we used to work with before. This and is it's kind of like we have to consider all of the bottom. Okay, so I'm gonna take in all of this at the bottom, but then as I take it, I start to look at the little circles and I see which ones are mandatory and which ones are not mandatory. All right. All right. Next slide over here. Is another example with more information in it. Okay. So this, again, vehicle is broken down to an engine, transmission, leather seats. Okay, so the engine is mandatory, transmission is mandatory, leather seats is optional, right? Now with the engine, you can see the symbol. Means it's an exclusive or. Okay, it means we gotta pick one, but only one. Okay, so I can have a V4 engine or a V6 engine. Obviously, we cannot have both engines at the same time, right? With transmission, it can be either manual or automatic. I'm sure nowadays there is cars that you can have both types of transmission, but that's really not the point here of this exercise. Okay, this, if you remember, this is the exclude relationship. Means if you're gonna have V4 engine, then you cannot have automatic transmission, and if you have automatic transmission, you cannot have a V4 engine, which means that automatic transmission in this case would only be applicable with the V6 engine. Okay, this little dotted box that you see on the side, this is what we call an attribute. An attribute is nothing, you think of it as a note, okay? A little box that just has some information about what other feature is linking to, okay? So about this automatic transmission, okay, we get 5-speed, and a whole lot of technical details that exist about it as well, all right? So is everybody following me so far, or did I lose anybody yet? Hey guys? Any questions so far, guys? All right. Okay, good. It's gonna get a little trickier, but it's not really that complicated. So we're gonna be good, inshallah. All right. Let me just make sure with the chat that everybody's all clear. Good. All right. Um, this, okay, in this situation, okay, I have one of the things that I have to have in my vehicle is safety. Okay. This is an or, means from the bottom, I can pick one or more. But then look at it this way. Although it's telling me I have to pick one or more, um, I have to have ABS, I have to have the air module, and I have to, but only the parking sensors are what comes as optional. All right. I'm going to talk about this little placing symbol and the group cardinality in a moment. This actually means it's like a hyperlink. Okay. So the airbag module has in itself within it a number of features. Okay. But usually for diagram comprehension purposes, so that the diagram is not too big and doesn't get too cluttered, uh, we have this little play button, which means a hyperlink button, and you click on it, and it's supposed to take you to a different diagram, and it shows you the entire set. Now, this over here, the let me just get the pen. The airbag module could have been A, B, C, for example. And when we have a group cardinality, that means that all of this is multiplied by either 2 to a maximum of 6. If we have the square one, okay, like say n to an m, that means this is a singular thing, and this could be multiplied by a cardinality of from m to a maximum of m. All right. So when we take a look at the airbag module, okay, this is the entire diagram for it, okay. And if you get the airbag module, you have to get all of these together, okay. Now, if we go back one last slide, remember it says 2 to 6. That means all of this is multiplied by 2, a minimum of 2 to a maximum of 6. So I get either 2 impact sensors, 2 inflator, 2 seat occupant sensor, or 2 airbags, or whatever it is I multiply from this range, I got to multiply it into the entire range over here. All right. So if I multiply by 3, everything is multiplied by 3. If I multiply by 6, everything is multiplied by 6. Okay. I don't mix and match. All right. Here's another example. Okay. So we said one of the things that we can have is a leather seat. If we do happen to choose the leather seat, okay, then I gotta pick all of these. Now, the way I read this is that I have an and over here, which means I gotta consider each one of those. Okay, and from under it, I gotta pick functions, actuators, and sensors. All right, within functions, I gotta pick those two. All right, with seat movement, I have to pick manual, but the electric feature is optional. All right, with the actuators, I gotta get the heater and the AC. All right, and the thing is, with the functions feature, right? If when we go down this route, because we have to, okay, that's if I happen to pick leather seats, all right, then this is called a require relationship, right? So if when I have that feature, I have to have an actuator, which means I have to have this and that as well. So that just comes along with it anyway. All right. At the end over here, I have to have a seat belt. Okay, and this is what we call a position sensor. There's a minimum and a maximum. So just the position itself could be multiplied by m to a maximum of n. All right, and if back over here, when we're looking at the seat movement, if I choose the electrical option, it's optional to choose it. But if I do choose it, then I have to pick along with it the position feature that comes with the sensors. Okay. So now the difference between just a regular and the required is that with the and, these are decompositions of the leather seats. Okay. Whereas this over here is not a decomposition. These are two different features from two different sub parts of the tree. Okay, so the electrical seat movement is not a type of position sensor, and the position sensor is not a decomposition of the electrical movement. They're two different features. Remember, it's kind of like saying this is an A plus a B. Remember the use case terminology. And it's a case of if you're gonna have electrical seats, you have to have that feature, you have to have that other feature, which is called the position sensor. All right. This notation over here is what we call a dead feature. Oh, come on, it's starting to do this. All right. Now, a dead feature is it's not something that we begin with, but usually it's a feature that we've had, and then after we keep updating the model, that we notice that there's no way that this feature is going to be selected. So in this particular example, we see that we have the let me go back to the laser pointer. If we're going to pick an entertainment center, which in itself is optional, we got to have an audio player and speakers. Okay, with the audio player, I got to have either the CD player or the cassette. Now, because I have to have speakers, speaker says there's a required relationship with the CD player. Okay, now this is an exclusive OR. Means if I pick the CD player, I cannot pick the cassette deck and vice versa. And because I have to have the speakers, which means I have to have the CD player, it means I cannot have in any sort of way the cassette deck. And this is called a dead feature. In other words, it's a feature that we will never be able to pick up at some point. And the whole point about modeling the dead feature is because at some point the cassette deck was a viable option, but as things have changed and as we updated and upgraded our models and the features and the different relationship between the different features, we've noticed and we want to show that this feature that we used to have before is no longer applicable. We cannot execute or have that feature included in our products anymore. And that could be for business purposes, so that we can stop producing cassette desks, which is actually the case in the real world anymore. I can't really imagine any cars nowadays are having cassette, not even CD players to begin with. All right. Now I'm gonna just go back here for a second before I get into this. I want to leave that out here. Okay. Now those over here, those three, we've covered those already. This is the attribute, the dotted one, okay, which was that one over here. Okay, so this is an attribute. It's nothing but a piece of information, just a note, textual note. Okay, this is a dead feature, and this is what we call a refer feature with the play button on the side. And like I said, the refer feature is what you would double click on and you go to a completely different diagram. And the whole purpose of this is that those diagrams tend to be really, really big, and we'll see examples of that pretty soon. And it's just sometimes for the purpose of being able to understand the model, I just cannot display everything in one shot, and I would leave a module to be hyperlinked with that feature. So now I see that, whatever it is that I'm going to click on, and it has its own feature diagram. Okay. Now, I want to step out here for a second. I want to share with you the whiteboard. All right. Okay. Okay. So we said this over here is an AND relationship. okay, right? And if I have a black circle, then I have to pick this. If I have a white circle, then maybe I pick it or maybe not. If I have a black circle over here, then I have to pick this one over here, okay? And we go back again, I wanna go like this. This over here is what we call the exclusive OR, okay? And it's a two-way thing, right? Just like with the AND says basically consider all of them. Okay, with the exclusive OR, it says consider all of them, but only pick one. All right. Now, if I have this as a black circle and this as a black circle, then we have an error. Because now you're telling me to choose two, you're forcing me to choose when the exclusive OR says I can only pick one. Okay. Just to, you know, if you think about it logically, so we've got an issue over here. All right. If I have them all circled in white, that's fine, because basically each one of them means I can take it or might not take it, but I'm gonna pick, I know I'm gonna pick one, and no one is shoved down my throat. Now imagine this scenario over here. If we put a black circuit over here, then the exclusive OR is one of those situations where I'm giving you the options, but you have to choose this one, all right? And because I'm choosing this one, that means I could never choose those ones, okay? Which then makes those ones dead features, okay? So it's a two-way thing, right? I'm considering the relationship as I come in from the above, but I'm also considering the circles that I have over the actual features, okay? With this one over here, yes, it's actually telling me that I have to consider all, oops, all of the features as I come down, but then as I get down, I am looking at the different circles that exist over those features, okay? Now let's move here to the side from the AND, okay? Let's do another AND, okay? But that other AND is, I have all the little white circles. Again, it means I'm gonna consider both of them, and I'm considering them with the intention that I'm gonna pick all of them. But as I go down, I realize that all of them are optional. Okay, and if all of them are optional, then that means I might end up with nothing. Because if I happen not to choose A or B or C, so despite it being an AND relationship, an AND decomposition, I might still end up with nothing at the end. All right. So you have to understand that the you know, it's a two-way relationship. It's the one that as you're coming down, you have to pick, you have to understand how to consider the boxes at the bottom, but then you have to look at the circles above it as well. Now, if we take the XOR and we actually look, and I'm going to fill this over here. So this is called an OR relationship. All right. That means I got to pick one or more. Okay. Okay. But at least one. All right. So here it's okay. I mean, if I have, say, let's just say the first situation. Okay. I got two black circles, one yellow. That means I got to pick this one, and maybe this one is optional. And that would be fine because I am picking at least one. Matter of fact, I'm picking two. Okay. Let's take another example. If we have all of them are white. All right. That might actually end up in an error because I might actually not pick this one, or that one, which means, you know, at the end of the day, I ended up with nothing. Okay, so that does violate the at least one situation over here. Okay. All right. The last situation, if I have them all circles like that, black circles, okay, well, I'm gonna end up picking all of them by force. Okay, and that's okay because that also satisfies my one or more. Okay, going back again to the XOR, if I have that situation, I think I already explained that. If I do have more than one black circle, then I do have an error because I'm forced to pick two when I'm only allowed to pick one or more. Now, one thing you should notice, all right, is that from a practical sense, those two end up being the same. All right. In other words, look at the bottom, you're gonna pick one or more. This one in here is actually saying, look at the bottom. You should be picking all of them, but then what you end up actually picking is up to you. The reason because we have this bit of a mess is that the notation for feature diagrams in itself, it started to grow on phases, right? So at one point, we didn't actually have the circles. We just had the lines, the three types of lines as such. Okay, this is the and, this was the exclusive or, and this is the regular or. Okay, let me draw the boxes at the top over here. So with the and, I just went out and picked all of them. With the exclusive or, one and only one. This one over here would have been one or more. Okay, with the circles, right? Those two end up being practically the same. Ended up being practically the same, right? Nowadays, you won't actually see a notation like this one. You'll see with the branching, the decomposition, you always see at the bottom an indication whether the feature itself is optional or mandatory. In other words, you'll see a circle above each and every feature, obviously, except for the root itself. All right. So I just wanted to explain this over here. Um, Now, let me go back again to the slides. No, no, that's not it. Okay. Okay. For the last two relationships, which we have those ones over here, this is a generalization and this is an implementation, and they have the same exact meanings like we've had all along. And now, what always throws up students off when we talk about generalization and implementation, there's a difference between generalization and decomposition. Okay. Now, generalization means one feature is a specific type of another feature, whereas the decompositions that we saw with the and the or and the x, or we're saying that something is made of something else. Okay, so let me explain this more clearly. For example, you have your laptop. All right, your laptop is decomposed into a number of components. You have the screen, you have the keyboard, you have the speaker, you have the mouse, right? Now we cannot say that each or any one of those is a specific type of a laptop, right? We can't say that the screen is a specific type of a laptop or that the keyboard is a specific type of a laptop, but the screen plus the keyboard plus the mouse plus the hard drive plus the motherboard and processor, the speaker together make up the laptop. All right. Now, if you want to think about it, you can say, okay, the relationship between a laptop and say an iPad. Okay, you can think that the iPad is a specific version of a laptop, which, if you think about it, the laptop that exists before, and you practically could do everything that you do in a laptop, you can do it in a tablet nowadays. So you can think like the tablet is a specific type of a laptop, okay, or a laptop is a specific type of a computer in general, okay. So this conforms to the definition of generalization which we've had before. All right, now uh, and following up is this over here is called the an implementation, and again the implementation has the same exact meaning as we've had before, meaning that if I have a feature, okay, it has to be implemented by the existence of other features that they themselves are not decompositions or direct decompositions of that feature itself. Okay, so let's take a look at example of those two over here. Let's go a little bit forward. Okay, so I have the safety aspect. Okay, but I also have another system that has a feature that warns the driver. Now you can see this over here is coming from a different subtree or different tree branch than this one over here. Okay, so safety in itself as a feature is decomposed into parking sensor, the airbag module, and the ABS. The warning of the driver is not a safety module, but is a feature that we want to have. So we say we can implement the warning of the driver, okay, by using ABS or parking sensor or both. All right. Whoops. All right. And like I was saying, the generalization and the implementation is the same as we did with use case modeling. So implementation means that this one over here, it has to be, it has to be implemented because on its own is not a complete feature. But with generalization, this could have been a complete feature on its own. And the notation is very, very tricky. And it's one of the things that, oh, there's an example. Okay. So, okay, this is an example. So, transmission could be semi-automatic, manual, and automatic. And you can think about it, actually, semi-automatic, this branch is a different branch than the automatic one. But the semi-automatic is a specific version of the automatic. And one of the things that we see that is not clear is which one is the parent and which one is the sub. We don't actually have an arrow direction. And it's one of the things that we don't like about the feature diagram notation, but it's not for us really to have that design. All right. But nonetheless, if we had semi-automatic, then we don't actually need to go ahead and implement automatic, and vice versa. If we have automatic, we don't need to implement semi-automatic. Okay, each one of those is a feature on its own. It's a standalone feature on which can work all by itself. But we're saying that semi-automatic is a specific version of the regular automatic. With this over here, I cannot just leave warning of the driver by itself. It has to be implemented. One of the implementation, I'm gonna grab features that exist under a branch that is not under me directly, under the warning of the driver branch directly. Okay, I have a question. Let's see the question over here. Okay, how do we show the direction of implementation? We don't. Okay, and this, yeah, man, it's a very good question. We don't actually have, the notation didn't come with an arrowhead, unfortunately. It's one of the big problems with it. But basically, you have to, at this point, just use your common sense. Okay, so you're seeing this over here. You're saying, I gotta warn the driver. I gotta warn the driver with ABS and parking sensor. It'll be difficult to read it in the opposite sense, saying, I gotta have ABS, and one way I can have ABS is to warn the driver. That doesn't make sense. All right, so it all depends on how I read and if it makes sense to me. Maybe they're not as obvious as this one over here. Is really semi-automatic a specific version of automatic? Or is it the other way around? We actually don't, I honestly, to be honest, I'm not really a big car buff, so I wouldn't really know which one would be the general, the specific type of the other one. And it's one of the things that we, it's a shortcoming of feature diagrams. All right. I want to move out here again to the white screen, because I want to just drive a particular point over here. All right. So we said here there's a difference between a direct decomposition. So all of this is within the branch of the parent feature that we had at the top. Okay. Those direct relationships with the bottom ones, okay, those are not generalization and they're not implementations either. Okay, they're just regular decomposition. okay, which meaning that this, okay, A is made of B, C, and D. Okay, now, so if this is one branch of the feature diagram, here we have another branch. Okay, now the relationship between those, sorry, branch, the relationship between a feature in that side of the branch and moving over here, let me just pick a different color, that other branch over here. All right, this is where I need to use the implementation or the generalization. Okay, if I have to, if I cannot have this on its own, then it has to be implementation. Okay, which means I have to get something from here, right? If I'm just trying to describe that there is some sort of a relationship between them, that one is a specific type of another, then I can just use the generalization one, okay? It wouldn't be a decomposition. Matter of fact, well, what is this? Matter of fact, when we saw a moment ago in the slide, we saw this happening, right? Right? And this is, we said generalization, okay? But that's okay, because if I happen to remove this from the screen and remove that as well, okay, then I would be able to consider that this is a branch 1 and this is branch 2. All right, guys? Does that make sense? Okay, so basically generalization implementation doesn't fit if it's something that is the direct descendancy of something else. All right. However, if we're coming in from a different branch of the feature diagram, then yes, we can actually have the generalization implementation. And matter of fact, we cannot have decompositions anymore. Okay, so A cannot be decomposed into B and B cannot be decomposed into A. Okay, guys, is that clear for everyone? We're gonna do some exercises, so you better be on your toes. If you have questions, you might ask them now. You should ask them right now. Guys, you ready? Okay. So, oh, I think there was, okay, we got a couple of questions about general, yeah. So what I was trying to say, yeah, man, in the very last thing that I was trying to say is that when we looked at that situation, okay, the difference, let's go here, the relation between C and a D is a direct decomposition, okay? The difference between C and A is a direct decomposition. However, the relationship between A and B, and by the way, sorry, this was a B, is not a decomposition. So B is not decomposed into A and A is not decomposed into B. And hence, this is why I can have a generalization relationship between them if it was applicable. Okay, so if I remember, this was one was automatic and one was semi-automatic. All right, you understand that now, Aman? Does that make sense? Okay, I'm going back over here. Everybody, all right. So now you understand the difference between straight up decomposition. So we're just going down from something. So A cannot be generalized or have an implementation with B, C, and D. All right. And but if I have something coming in from a different branch, like E, different branch of the diagram, then I can have implementation or generalization. And matter of fact, I cannot have a decomposition anymore, okay? Because it's too late. B is the decomposition of A. All right. And it's true because we actually have a tree structure. And one of the properties of the tree structure is that if I have A and it's decomposed over there to say, let's say B and C, okay, I have another feature here called E. It cannot be decomposed into say F and C. So this is not allowed. Okay, C, the leaf, okay, can only belong to one parent, either the A or the E. Did that last part make sense too? So we gotta have a tree structure, okay? We cannot have a mixing and the matching between the different branches of the diagram. Okay, guys, so you think you're ready for the exercises? We'll do the exercises. All right, so I'll take that as a yes. All right, now what I want you to do is open up your Moodle. Let me pause the recording for a second.